Hello everyone. For this tutorial video, I like to explain how multiple inductors work, whether in series or parallel, and the formulas to find the total inductance, similar to what I did for total resistance earlier. If you remember from a previous tutorial video how the voltage drop across an inductor can be a good objective measurement of its inductance, then it should hopefully make sense that inductors in a series add up, exactly like how voltages in a series add up. However, parallel inductances are not as obvious and are more tricky. But if we remember, in a parallel circuit, the currents add up, so the current across one inductor is less than the total current, and that the voltage should generally stay the same across each inductor. It should become somewhat easy to observe that the total inductance in parallel must be less than one of the individual inductances, as a change in total current will mean a change in the voltages across the inductors. And in particular, if there is less current, there is less voltage. And also, fortunately for us, the formula for parallel inductances is the same exact as the formula for parallel resistances. The only thing that is different is inductance rather than resistance. Now that I've explained how total inductors work, either in series or parallel, I can begin discussing complicated circuits that involve resistors, capacitors, and inductors at the same time, starting with an explanation of how to calculate charge times for capacitors and inductors in a DC circuit, and then graduating to AC circuits, as those more commonly use inductors than DC circuits do. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.